Lesson 54, we're on 54, talking about polar and rectangular coordinates. Now it looks tough, but it's really no big deal. It's not too difficult at all. It's just using rules that you've really done since geometry. And so we're going to expand on some of those, turn them into some problems. Let's look at polar coordinates. What is a polar coordinate? Well, a polar coordinate can be written like so. It's got 4 in this angle sine 57 degrees. That is read 4 at 57 degrees. That's how that is read. Well, how this would look like on a coordinate grid is, imagine, okay, here's our y and x axis. All right, this is a horizontal line. Let's treat this line as 0 and 360 degrees. I'll show you why. When we do polar coordinates, this 57 degrees, we start here and go counterclockwise, 57 degrees. So 57 degrees is roughly right here. And that's where we stop and create our 4. Our 4 is the length of the vector. This is actually referring to a vector. And that's what the 4 is. So this is how you would write or draw 4 at 57 degrees. Now if something is beyond 90 degrees, let's look at this one, 7 at 230 degrees. Well, we start in the same place, 0 and 360. Because a full circle is 360, that's why I put 360 there. Well, this is 90, since this is a right angle. A straight line is 180. The third spot would be 270. So if an angle went from here to here, it's 270. This says 230. Well, 230 lies between 180 and 270. So therefore, it would look something like this. And then you were, in most problems, you will actually figure out the measure of this angle here. 230 is the total, but what is the measure of that angle? And to find that, you would always subtract what you have, your total, minus your, or you would find the difference of your total and your horizontal. Our horizontal here is 180 degrees. And so this angle would be 50. And that's how you would do that. If it was, let's call it, say it was 100. If it was 100, well, you could do 100 minus 180 and do the absolute value, or you could do 180 minus 100. Either way, it'd be 80. But that's how you do that. Now let's look at rectangular coordinates. Rectangular coordinates are written with the letters R and U. R means right, and U means up. So if you have positive 3R plus 5U, if we look on the coordinate grid, these start from the origin. And then you go 3 to the right. This is a vector. You go 3 right. So this would have a measurement of 3. You actually don't need the R there. And then you go 5 up. Okay, so you go 3 right. Don't let your pencil leave the ground or the paper. Then you go 5 up. And so that would be your rectangular coordinates. And this is the triangle that it would create. And we'll get to that later. If you had negative 3R minus 5U, well, negative, we don't actually say 3L, meaning 3 left. What we do instead is say negative R. So that would be like negative right, so that just means the opposite of right, and that means left. So start the origin and go 1, 2, 3 to the left. Once again, don't need a negative. Negative is not a measurement, something you can like measure with a ruler. And then you would go 5 down, since it's a negative 5U, and would write 5 there. But that's how that triangle would look. If it was positive 3R and negative 5U, it'd be here, and then down. And that's what that would look like. But that's rectangular coordinates versus polar coordinates. Now let's look at some problems with these. Example 54.1. It says convert 4 at 57 degrees to rectangular coordinates. Well, here's how you do it. You first draw it, just like we've done. Here's my 0 and 360. I'm not going to do any further since we know that 57 is between. You go counterclockwise. Start here, go about 57 degrees. Doesn't have to be perfect by any means. 57 and 4, and we draw that. Now what we want to do from this point is actually create a triangle with the horizontal. Have to create it with the horizontal. We don't connect to the y-axis. Connect to the x-axis. Always. So now what we have is a triangle that looks like this. I'll enlarge it. It's a 90-degree angle perpendicular that we made. And now we're in a position where we need to find our R value, horizontal, and the U value. And so we simply use our trigonometry. So, TOA, to find R and U. So if I said sine of 57, that actually equals opposite, O is for opposite, opposite here is U, over hypotenuse, and our hypotenuse here is 4. Then you can multiply 4 to both sides. 4 sine 57 is 3.35. So R equals 3.35. Now we do, since we want to use, sorry, I always do that, I don't know why. We found U. Now we want to find R, and so we need to use something with adjacent. Well, let's use adjacent and hypotenuse. Which one uses that? That would be cosine. So cosine of 57 equals adjacent R over hypotenuse 4. Multiply by 4. 4 cosine 57 is 2.18. So here's our two answers. But let me show you how we write it. We write it like so. 2.18R plus 3.35U. Do the R first, and then the up and down measurement, or X and then Y, or X-axis then Y-axis, sorry. But that is how you do polar coordinates to rectangular coordinates. Let's look at one more that's a little more tricky. Example 54.3. 42 at 340 degrees to rectangular coordinates. Okay, so this one's going to be a little bit bigger. I'm going to use all of our spots here. Now 340, where is that between? That's between 270 and 360. So we're going to have to go all the way around somewhere like right there. So this angle is 340 degrees, and the hypotenuse is 42. Got Pac-Man in there. Well, like I said, we do not create a triangle with the y-axis, we create it with the x-axis. So we have a triangle that looks like this. So we have R, U, and 42. But we need this angle. This angle is not 340. Like I said before, this angle that we're looking for is always the difference, okay, of the reflexive angle, or the angle you have, and the x-axis. So I'm going to do my bigger one, 360 minus 340, and that equals 20. If I wanted to, I could write 340 minus 360. I would just have to know that it's the absolute value, and thus being 20 as well. So my degree here is 20. And now we can solve. Sine, just so you know, just a little hint here, from polar to rectangular, it's always going to be sine and cosine. So sine of 20 equals opposite u over hypotenuse 42. Multiply by 42. 42 sine of 20 is 14.36. Okay, u 14.36. And now we need to find r. We find r by doing cosine. Cosine 20 equals r over 42, adjacent over hypotenuse. Multiply 42. 42 cosine 20, 39.5 is what I'm going to round it to. Okay, like I said before, we write our answer in R and U format. So we write 39.5 R. Now this R was actually positive, so it stays positive. Notice the U, though, it doesn't go up. It doesn't go in the first quadrant. It goes down. So since it's down, we write a minus sign, 14.36 U. And that would be your answer. 39.5 minus 14.36. My answer is like decimals off from the book, but I would count that correct. And that is polar coordinates to rectangular coordinates. Now let's look at one more concept here. In 54b, it gives two triangles that it says are similar. It says these angles are congruent, and then it just gives letters. Okay? If it just gives letters, what these problems, it actually doesn't give a practice problem or example problem. It gives practice, but not example problems. If it says solve for A, all we have to do is, well, we know these triangles are similar. These are vertical angles, so angle means the triangles are similar, and so they're proportional. So we can create a proportion. I can say A over C, since I'm doing this side in the big triangle over the bigger side in the triangle, equals B over D, the parts that correspond on the other. Now from here, to solve for A, we have to cross multiply. AD equals BC. And then to solve for A, divide by D. BC over D equals A. And that's all you have to do for the part of similar triangles. Really don't need to spend any more time on that. But that is the end of lesson 54.